Welcome back to the channel. I'm Ryan from EduSummer, and today we are going to dive into Chapter 3 Form 4 Chemistry. And it's called the mole concept and the chemical equation and formula. For the first subtopic, we're going to discuss about RAM and RMM, relative atomic mass and relative molecular mass. They are basically the same thing, but one is just for elements, while the other one is for the molecules or the molecules. So RAM, let me just tell you that for RAM, for every one proton or neutron is equal to 1 unit of relative atomic mass. Just remember that. Also applies to relative molecular mass. Just remember that. It's easier for you to understand. Okay, now the formula for relative atomic mass is actually the average mass of an atom divided by 1/12 of carbon 12. Why do we need to multiply by 1/12 for carbon 12? Because as I said just now, one proton or neutron is equal to 1 relative atomic mass. So in order to make it so it is 1 unit, we need to multiply 1/12 of the carbon 12 atom. Because carbon 12 is a nuclear number. Nuclear number is the total number of proton and neutron. So you need to divide by 12. Then you might ask, why do we need to use carbon 12? Why don't just use hydrogen, since hydrogen is only one nuclear number? Because in older chemistry, they used to use hydrogen, but because it's very light and it's not as common in chemicals, and it's also very hard to weigh them since they are so light, right? They also exist as a gas in room temperature. So they just use carbon. Since carbon is a solid in room temperature, it's very easy to weigh since it is heavier, and it also combines with a lot of chemicals. For relative molecular mass, you just need to add all the nuclear number of all the atoms in the specific molecule. For example, carbon dioxide. Carbon dioxide has 3 atoms, 1 carbon and 2 oxygen. So what is the relative atomic mass for carbon? It's 12. What is the relative atomic mass for oxygen? It's 16. So 12 plus 16 is equal to the relative molecular mass for carbon dioxide, which is 44. You need to remember that relative atomic mass and relative molecular mass has no units. So they just put, for example, relative atomic mass of carbon is 12. They just put 12 units. There's no specific value for it. Now let's go into mole concept, which is very confusing at first, but once you get used to it, it's quite easy. Even myself, when I first deal with mole concept, it's actually pretty hard. For everyone, even how smart you are, you will always get confused with the mole concept at first. So just bear with me right now, and I'm gonna explain step by step what is the mole concept. To understand the mole concept, we need to first know what is the Avogadro's number. Avogadro's number is a number created by Avogadro, very obvious. But the value is 6.022 multiply 10 with the power of 23. But you can just search it online, it's very easy only. Just search it online, it's very easy. 1 mole, the unit mole is actually a SI unit. This SI unit is a base unit, meaning that it cannot be derived from other formulas or units. You might already learn this in physics. For 1 mole is equal to 6.022 multiplied by 10 with the power of 23, which is the Avogadro's number. Just imagine this as like a bag of rice. We don't choose how many rice do you buy, so I just buy 1 bag of rice, which is equal, I don't know how many little rice grain there is. We just need to know that it's 1 packet of rice. It's the same as the mole concept. 1 mole equal to 1 bag of rice and equal to this Avogadro's number of atoms or rice grain. Just remember that so it's easier for you to understand the mole concept. Now let's get into the molar mass. Molar mass is actually equal to the relative atomic mass and the relative molecular mass. You might ask, why is it the same? So they just make it easier, so the relative atomic mass is equal to the molar mass. But there's a difference between molar mass and the relative atomic mass and relative molecular mass. The difference is that molar mass has a unit, meaning that you can use it to calculate other things already. But for relative atomic mass and relative molecular mass, it doesn't have any units. For the molar mass, it's actually grams per mole. For the molar mass of carbon is 12 grams per mole, meaning that a bag of carbon, I'll just take the example from just now, a bag of carbon is equal to 12 grams. To get the number of mole, you take the mass of the substance and divide it by the molar mass of the substance. Then you will get it already. Very easy. This is the formula, but to me, I much prefer to use the unit behind them, because for mass is G. The molar mass is G mole negative. If you don't know, negative meaning is divided. So when you divide, it becomes a multiply. So G divided by G is nothing. So it is gone, while the mole becomes mole only. It is not a negative anymore since it is divided again. So it becomes mole. Very simple. Just look at the unit and you'll figure everything out. Very easy. But you need to be careful of one thing. When you're answering or reading the question might ask you to give them the number of mole of atom or the number of mole of molecule. There's a very big difference there. Now, I will give you an example. The question gives you 18 grams of water, meaning H2O. The mass of the water is divided by its molar mass to get its number of mole, which is 1 mole, because the molar mass of the water is also 18 grams per mole, because 16 for oxygen and 2 hydrogens. Hydrogen is 1. Now, if the question asks for the number of mole of molecule, it is 1 mole of molecule or particle. But if the question asks the number of mole of atoms in 18 grams of water, you need to multiply by 3, because the molecule of water is H2O, meaning there is 2 hydrogen and 1 oxygen. So you need to multiply by 3. So the number of mole of atom is 3 moles. So next time when you're doing a question like this, please be careful and read properly the question and what the question is asking for. Now that we already know the molar mass of something, it's time to go into the molar volume. Molar volume is slightly different than molar mass, because molar volume is the same for every substance, molecule or element, whereas the mass is different for every other thing. The molar volume stays the same as long as the pressure and the temperature stays the same. So the volume the particles occupy is the same. Under the STP, which is standard temperature and pressure, the molar volume is 22.4 decimeter cube per mole. So you might ask, what is the standard temperature and pressure? The temperature for the STP is 0 degrees Celsius or 273 Kelvin. The pressure is 1 ATP, means just the normal atmospheric pressure. And then there's the room condition, 24 decimeter cube per mole, which is 25 degrees Celsius and 1 ATP. So if you want to get the number of mole for a certain volume of gas, it's actually quite easy. You just take the volume of the gas and divide it by the molar volume under the specific conditions. The specific condition will be given in your exam, so you don't need to worry about that. But please be careful of one thing. The question will always trick you by using a different unit of meter, because molar volume, it works for decimeter cube. So you need, when you are doing the question always give you the centimeter or meter. Remember to convert it before you put into this formula. Remember, decimeter is 10 times smaller than meter. But you need to be careful of something. The is a decimeter cube, meaning you need to divide it by 3 times. You divide 10 divided by 10 divided by 10. 3 times of 10 or 10 cube. Whereas for the centimeter is 1/100th of a meter. So you need to divide it by 100 by 100 by 100 or 100 cube. But when you do convert from centimeter to decimeter, you need to divide it by 10, 3 times. See, meaning 10 cube. Very easy, very simple. If you look at the textbook, they already given you a diagram which relates the mass, the volume, the particles, and the number of mole. But I do not recommend you guys to memorize this diagram because it's kind of hard. It is way easier if you just look at the units, write the units out, even though it might be a little 麻烦. Just write it out. It's simple for you and you can get a very accurate answer. If the unit is correct with the specific thing you are finding, then the answer is automatically correct. So you don't need to worry about, oh, I need to check this, check that. No need. It's very easy only. Okay, and that's it for the video for chapter 3 part 1 of the video. If you enjoy, please like and subscribe, and see you next time. Bye bye. It's around here.